we can say that ROC is the exterior of a circle of radius mod A. So ROC is exterior of a circle of radius mod A. If A is equal to 1, if A is equal to 1, then xz is equal to 1 by 1 minus z to the power minus 1 mod z greater than 1. Now let us come to the second example. Now let us come to the second example, where example number 2, that is xn is equal to minus a to the power n u minus n minus 1. It is an anti-causal sequence of infinite duration. It is anti-causal sequence of infinite duration. So in that case, x, z. So it is anti-causal sequence. So here xn is an anti-causal sequence for infinite duration. You can see that from the expression that it is u minus n minus 1. So it is anti-causal sequence. So now the z transform will be n equal to minus, from minus infinity to minus 1, minus a to the power n, z to the power minus n. So it will be equal to minus summation of m is equal to 1 to infinity a to the power minus 1 z to the power m, where m is equal to minus n. Now we know that c plus c square plus c cube plus dot 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 is equal to c by 1 minus c, where mod c is less than 1. So therefore xz will be equal to minus 1 minus a to the power minus 1 z by 1 minus a to the power of minus 1 z, which is equal to 1 by 1 minus a z to the power minus 1. If a to the power minus 1 z modulus of it is less than 1, then mod z will be less than mod a. Z transform of minus a to the power n u minus n minus 1 is equal to 1 by 1 minus a z to the power minus 1. ROC is mod z less than mod a. The ROC is here the interior of a circle of radius mod a. ROC is here the interior of a circle of modulus a and centered at origin in the z plane, and centered at origin in z plane. ROC of the Z transform of a causal signal is the exterior of a circle centered at origin, and that of an anticausal sequence is the interior of the circle centered at the origin. Thus, a uniformly sampled signal Xn is uniquely determined by its Z transform Xz and the ROC of Xz. So, an uniformly sampled signal Xn, please note that uniformly sampled signal Xn can be retraced back from its Z transform and the region of convergence of Z transform, So, retraced. Now let us come to the third example. Now let us come to the third example, that is xn is equal to a to the power n un plus b to the power n u minus n minus 1. This is from this expression you can understand that this is a two-sided infinite duration sequence. Two-sided infinite duration sequence. So hence xz will be equal to what? That is summation of n equal to 0 to infinity a to the power n z to the power minus n plus summation of n equal to minus infinity to minus 1 b to the power n z to the power minus n. So it is equal to summation of n equal to 0 to infinity a z to the power minus 1 to the power n plus summation of m equal to 1 to infinity b to the power minus 1 z to the power m. The first sum converges, this sum converges if mod z is greater than mod a, and the second sum converges when mod z is less than mod b. Mod z is less than mod b. So do you understand all this? I hope you are understanding. Now let us consider number 1 when mod b is less than mod a. So two ROCs do not overlap. XZ does not exist. Number 2, if mod B is greater than mod A. So in that case, there is a ring in the Z plane with inner radius mod A. It is like this, inner radius mod A and outer radius mod B, where both power series convergent simultaneously. This is mod A and this is mod B, where both the power series converges simultaneously. Thus xz is equal to 1 by 1 minus a to the power z to the power minus 1 minus 1 by 1 minus b to the power of z to the power minus 1, where mod a less than z less than mod b. Mod a less than z less than mod b. This example shows that if there is a ROC for an infinite duration two-sided time series, it is an annular region centered at origin in the z plane. Centered at origin in the z plane. So, you can say that if this is mod B and if this is mod A, then Z transform does not exist. So I hope with these three examples your idea on region of convergence will be clear, and you practice several other sums so that it will be further clear and you will have a concrete concept on the region of convergence of Z transform. With this, our series of lecture on mapping of S plane to Z plane is come to an end, and we will again talk to you on IIR filter design in our next lecture. Thank you.